Indices and logs. Logs, type 6, real-world problems. So we've looked at all of our log rules and solving log equations. So now what we're going to do is look at our logs in real-world situations. So these can range from looking at the Richter scale, looking at the decibel scale, looking at pHs, and even looking at interest rates. So our first example is going to be where our equation is given to us in index form. And we're going to look at our Active Maths textbook, book 1, page 190, and we're going to do question 3 as our example. So with all of these real world problems, we don't have to have a background in physics or geography or business, because all of the information provided in the question should allow us to understand what each of the letters represent and what units the quantities are going to be in. So this question 3 is around radioactive decay, and the particular substance that we're looking at here is iodine 131. And we're given a little bit of background information where we're told that it's used in medicine to measure liver and heart activity in the treatment of certain cancers. But the main thing that we're looking at here really to pick out and decipher is that we're told it has a half-life of 8 days. In other words, the quantity of iodine 131 decays by a factor of 2 in 8 days. So we're starting with an amount of 30 grams of iodine 131, and we're told in 8 days 15 grams remain. And that's basically because we're looking at the half-life. So we were told the half-life is 8 days, which means that after 8 days the quantity will have halved. So therefore 30 grams halved is 15 grams. Now we're given the decay is modelled by using the exponential model Q equals A e to the power of bt. So most of these equations that are going to be in index form are going to be written in this format here. Sometimes A and B are given to us. In other words, the numbers are given to us and we might be asked to show that A and B is equal to those numbers. Or in this particular case, we don't know what A and B are and we have to actually start our question by solving for those constants A and B. And these are constants. So that means that once we find them, they're going to stay the same for the rest of the question. Now, the other thing to note is obviously that our T is time, and that's measured in days. So I always like to start by stating what each of my letters represent in the question and what unit they are measured in. So Q is my quantity of iodine 131, and it's measured in grams. T is my time, and that's going to be measured in days. And then A and B are both constants. So with regards to solving the first part of the question, we have two letters to solve for, A and B. We will always start by finding A first. And to do this, we're going to start at the beginning. What information do we know? Well, at the start, the time is 0. And we know that we've started with a quantity of 30 grams of iodine 131. I don't know what A is, and I don't know what B is. So I write down my given equation, Q equals A e to the bt, and then I just simply sub in my numbers. So Q is 30, A I don't know, B I don't know, but the time is 0. So that's nice because it gives me e to the power of 0, because b times 0 is 0. And of course we know that e to the power of 0, or anything to the power of 0 for that fact, is always going to be 1. And therefore that gives me 30 is equal to A times 1. In other words, A equals 30. So no matter what type of equation we're given in this format, we'll always start by letting t equals 0, sub in the quantity at the beginning, and then that will always give us A equals. Okay, so then to find B, we have to look at, well, what's the second piece of information given? So I can't use t equals 0 again, because that'll only ever give me A. So I have to look at the next period of time in the question, and that's this one here. If I just put a little star next to it, In 8 days, 15 grams remain. So basically what we're looking at is 8 days later. So that means that the time is going to be 8 days. The quantity is 15 grams. And we now know that A is going to be 30. So this time we only have one unknown. So writing down my equation, Q equals A, e to the power of bt. I sub in my quantity, which is 15. A is 30, e to the power of b, we don't know, times the time, which is 8. Now, we cannot try and isolate b here on its own. So what we're going to have to do is apply our log rules. But before I can apply the log rules, I have to have e on its own isolated. So therefore I must get rid of this 30. So I'm going to divide both sides across by 30. So we have 15 divided by 30 equals e to the power of b times 8. So that's just going to be 8b. Now if you look at the left hand side, that's quite interesting for this particular question because of course 15 divided by 30 is a half. And of course that's because we've looked at one half-life, and after one half-life, half of the substance remains undecayed. So hence half on the left. So to isolate the 8b on its own, I have to apply my log rules, and the only way I can find an unknown power is to have log of both sides. So I'm going to get log of both sides, and I'm going to get the natural log of both sides. And that's because we have an e here. So if I get natural log of one side, I have to do the same to both sides to make sure my equation is balanced. And of course, then if I look at page 21 of my maths tables, this is my third rule down on page 21. When I have a log raised to a power, I can bring that power down in front of the log. So therefore, that's natural log of a half equals 8b times natural log of e. And of course, what's natural log of e? Well, we love that because it's always going to be 1. So therefore, that gives me natural log of a half equals 8b times 1, which is just 8b. And therefore, to get b on its own, I'm going to divide both sides across by 8. And what's interesting about this is, again, I can go back to my log rules. I have one number divided by another, which is the second rule down. So that can be written as natural log of 1 minus natural log of 2 over 8. And natural log of 1 is always 0. So therefore that natural log of a half divided by 8 actually simplifies to minus natural log of 2 over 8. Now in the exam, we could be asked in the leave insert to leave it in log form, or we could be asked to write that as a decimal correct to so many places. So if I put minus natural log of 2 over 8 into my calculators, or I put in natural log of a half over 8 into my calculator, I get b equals minus 0.0866. Of course, that would be correct to 4 decimal places. In the leave insert, if they asked for 3 decimal places, it would be minus 0.087. So you always want to check, do they want it in decimal form or in log form as my answer? Now the interesting thing to note about B is that it is negative. And when we have a negative value for B, what we're looking at is a exponential decay. And of course, radioactive decay is going to be a negative decay. If the value for B is positive, then it's going to be an exponential growth. Okay, so if we go back to our question, we've now done part 1, so I'm just going to tick that off. So part 2 says what quantity, so quantity means we're looking for Q, is going to remain after 20 days. So our time is going to be 20 days. We're looking for Q. We've established that A, our constant, is 30. And we've just established B, the constant, and I'm going to take it as minus natural log of 2 over 8. So this is going to be the most accurate value unless stated otherwise in the question. And again, I'm going to sub in to my equation. So I have Q, I don't know, is equal to A, 30, e to the power of minus natural log of 2 divided by 8 times the time, which is 20 days. So that's quite easy and straightforward. We make sure we put that into our calculator. Make sure you're using your brackets. And then that will give us a quantity of 5.3 grams remaining after 20 days. So we can take that one off and we look at the third one, and it says find the time taken for the substance to decay to 1.49 grams. So this time we don't know the time, but we do know our quantity is going to be 1.49 grams. So our time is unknown. A is our constant 30, B is minus natural log of 2 over 8, and Q is 1.49 grams. So again, if we go to our equation, all we're doing is subbing in our numbers and trying to isolate T on its own. So we have 1.49 equals 30 e to the power of minus natural log of 2 over 8 times T. Again, we can see we have an unknown variable in the power. And when we have an unknown power, that means we're going to need to get log of both sides. But I cannot get log of both sides until I have isolated the e on its own. So that means I need to get rid of that 30 in front of the e. So by dividing both sides by 30, I now have e on its own, which now means that I can get log of both sides. If I get natural log of both sides, well, that's going to allow me to apply the same log rule we did for working out what b was. So if I go back, it was our third one down again, where I can bring down my power. So by bringing down the power there, we have minus natural log of 2 over 8 times T multiplied by natural log of E, which is of course 1. So therefore that gives me natural log of 1.49 divided by 30 equals minus natural log of 2 over 8 times T multiplied by 1. So now to get T on its own, I'll divide both sides across by minus ln 2 over 8. And again, making sure you're using your calculators and checking in the exam how many decimal places do they want our answer, or to the nearest what? Time, day, month, year. So in this case, our time is in days, so it's just 34.65 days approximately. Our second type of real world problems is where we're going to be given percentages. So this question really is going to come up in financial maths later on in 6th year. And we'll use this equation for pretty much the whole chapter of financial maths. So it's a nice little kind of introduction to it here in this section in logs. So again, we don't need to know anything about business, but of course all the information is given to us here in the question. So again, I'm going to start by listing what the letters are in the equation. So the equation given to us is f is equal to p times 1 plus I to the power of t. So we can see that f is representing our future value. And again, we'll take it to be in euros. So it's going to be an amount. P is going to be the present value. And again, that's going to be in euros. I, we're told, is the annual rate of interest. And when subbing this value into our question, into our formula, I should say, we must always write it in decimal form. So it'll be given to you in percentage form, but of course going into the equation for I, it'll always have to be in decimal. And then T is going to be our time. And again, if we look at the question, our time is in years. So I'm only going to do the first part because obviously it's just repetition after that, 7% and 10%. And we have to give our answer correct to the nearest month. So the information given to us here in the question is we have to use logs to find the time taken. So we're looking for t, and the investment is going to double in value. So what that basically means is that the future amount is going to be double the present value. So f is going to be equal to 2p. Our interest rate is 5%. So as a decimal, that's going to be 0.05. And t is what we're looking for. So if I sub that into the equation, f equals p by 1 plus I to the power of t. Then f is going to be 2p. P is just p. 1 plus I, well, that's going to be 1 plus 0.05 to the power of t. So like the previous one, we can see that we have an unknown power. And when we have an unknown power, we need to get log of both sides. But before I can get log of both sides, I need to get rid of the number in front of the exponential part. So basically, I'm going to divide both sides across by p. So 2p divided by p is just simply 2. 1 plus 0.05 is 1.05 to the power of t. And now I can get log of both sides. So if I get log of both sides, that's natural log of 2 equals natural log of 1.05 to the power of t. I can now apply my log rules. So again, that's the third one down on page 21, where when I have it raised to a power, I can bring down the power in front of the log. And now I need to get t on its own, so I'm going to divide both sides across by natural log of 1.05. And then if I put that into my calculator, and we have to be careful in our calculator to make sure that we close the bracket. So when you type in natural log of 2 over natural log of 1.05, you have to physically close the bracket on the top and the bottom, otherwise you're going to get a maths error. And that will give us a value of t equals 14.2 years. But again, if we go back to the question, I'll put a little star next to it. It said correct to the nearest month. So of course we need to multiply our 0.2 by 12 months, and 12 times 0.2 gives us 2 months approximately. So therefore that's going to be 14 years and 2 months. So the third type is where we're given an equation which has logs in it. And this equation comes from the old Active Maths book from the first edition, and it was example 7.15 on page 151. So we were given this equation for the decibel scale, which is represented by 10 log I over I0. So again, we don't need to know all of this information off by heart. Instead, it's given to us in the question. So we're told that D is equal to the decibel rating, and decibels are measured in small d, capital B. I represents the sound intensity, and the sound intensity then is given to us in watts per centimetres squared. So in other words, power over area is how we measure our sound intensity. And then we have I0, which is our standard sound intensity. So in other words, that's what we're comparing everything to. And we're given that value, we're told what it is. It's 10 to the minus 16 watts per centimetres squared. Now again, if we note here, our log has no base, and we remember that when logs have no bases, it's actually log to the base 10. Okay, so the question basically wants us to work out what is the decibel rating, when the sound intensity, so in other words, when I is equal to 10 to the minus 10 watts per centimetres squared. Okay, so subbing in our values, we have D is equal to 10 log. I is 10 to the minus 10 over I0, which we're given is 10 to the minus 16. And we can sub that straight into our calculators and work out what D is. But of course, I'm just going to do a quick recap on our indices because that's always nice. And what we can see here is that we have base 10 for both, and we can subtract our powers. So our basic log rules tell us that, or basic indice rules tell us that when the base is the same, we can subtract the powers when dividing. And this is, of course, the second rule down on page 21. So that's 10 log 10 to the power of minus 10 minus minus 16. And of course, that's basically 10 log 10 to the power of minus 10 plus 16, which is power of 6. And then if I again look at my log rules, I have a log raised to the power, which means I can bring down that power. So if I bring down the power of 6, I have a 10 in front of that. So it's 10 times 6, which is 60 log 10. And of course, log 10 is the same as log 10 to the base 10. And of course, log of any number to the same base is always 1. So that gives me decibel rating of 60 decibels. Now, of course, as I said at the start of this example, we can go from the first line to the last line in our calculators, but it's always nice just to practice those indice rules wherever we can. So on page 190, we can do question 1, 2, and 5.